Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, we're going to learn how to write ionic names and formulas, this time with polyatomic ions and with transition metals that can do different cations. Okay, so what do we want to accomplish in this webcast today? First, we need to review how to name transition metal cations, the ones that have variable charges. The textbook I teach from calls these type 2 cations. And then we're going to do some formula writing for ionic compounds, specifically ones that contain polyatomic ions and these type 2 cations. And finally, we're going to write names for these ionic compounds using stock notation, which is the system that we use when we have these variable charges for our transition metals. So let's talk for a moment about transition metal cations. One of the hallmarks of transition metals is that they can form cations with different charges. They can take more than one charge. So for example, gold forms two different cations commonly, Au plus and Au plus 3. We can't just say gold ion because we don't know in that case if we mean the ion with the plus 1 charge or the ion with the plus 3 charge. We need to be a little more specific. So we're going to use Roman numerals to indicate the charge of the cation. So instead of saying Au plus, we could call it gold 1. And Au3 plus is called gold 3. So the Roman numeral tells me the charge of the cation. So actually, this brings me to an important point. We know that the group 1 metals always form plus 1 ions. We know that the group 2 metals always form plus 2 ions. Silver only forms plus 1, zinc only forms plus 2, aluminum only forms plus 3. Your teacher might have talked about gallium only forming plus 3 as well. But these ions, these metals only form these ions, and so we never use Roman numerals with group 1 metals, group 2 metals, silver, zinc, and aluminum. Ask your teacher if they want you to use other ions in this list as well. You have to know when to use a Roman numeral and when not to use a Roman numeral. That can get tricky. The other thing that I wanted to point out is that it's really important to know your polyatomic ions. A lot of chemistry teachers want their students to memorize the common polyatomic ions, and if your teachers ask you to do that, you need to make flashcards and practice them every day. Maybe make a Quizlet. Practice, practice, practice. Otherwise, you need to be familiar with them, because if you don't recognize the names or the formulas as being polyatomic ions, you're going to be lost really quickly. If it ends in ate or ite, it's probably a polyatomic ion, and you need to know them. So let's review the process for writing formulas for ionic compounds. It's pretty much the same no matter what kinds of ions you have. Write the cation first with its charge as a superscript, and then the anion right next to it with its charge as a superscript. So cation, then anion. And then we need to make electrically neutral compounds. So the sum of the total charges from the cation, or cations, has to equal the sum of the negative charges from the anion or anion. So we can have multiple copies of these to make it work. I like to think about the lowest common multiple of the charges, and I use that to figure out the subscripts so that the sum of the charges will be 0. That's a really important point. If I want to show multiple copies of a polyatomic ion, I'm going to write that polyatomic ion inside parentheses and then put the subscript that I need outside those parentheses. The other thing that I want to point out is we don't show any charges in the formula. Ionic compounds just show the anions and the cations, whatever atoms those involve, but no charges are shown in the formula. And that means no Roman numerals either. And that's an error that I do sometimes see. But you know better. You know that you won't show your charges in your formula. And let's go through how to name ionic compounds briefly before we start doing some practice problems. The rules are always the same. It's the cation name and then the anion name. But we have to remember for those transition metals that can form more than one cation, we need to put that Roman numeral in because that's part of the name of the cation. So for our transition metals that can form more than one cation, you may have to figure out what that charge is and put the Roman numeral in. So that can be a little bit tricky. You may have to do a little algebra. It's okay. You can handle it. You've got this. The other thing I want to point out is that the names of ionic compounds do not give any information on how many of each type of ion are present. So you don't use prefixes like di or tri or anything like that when you're naming an ionic compound. So again, don't be fooled. Don't be tempted. You know what to do. Do the right thing. Let's do an example problem. We'll do several example problems. You know I love to do example problems. Give the correct name and formula of the compound that's formed between cobalt 2 ions and acetate ions. So we've got cobalt 2 ions. Remember, the Roman numeral 2 tells us that the cobalt ion has a charge of +2. And then acetate, you either know it or you looked it up on your list of polyatomic ions. The acetate ion can be written as C2H3O2-. It's got a -1 charge. So if we look at these two ions side by side, if they were to react in a 1-to-1 ratio, that doesn't give me a neutral compound, right? The sum of the charges wouldn't be 0. But if I had 2 acetate ions, now I've got 2 pluses from the cobalt ion and a minus from each of the 2 acetate ions, that adds up to 0. So I need 2 acetate ions for the cobalt ion. So my formula becomes CO parentheses C2H3O2, close your parentheses, 2. And the name, remember, it's the cation name and the anion name. So it's cobalt 2 acetate, right? And notice the acetate ions in the formula are in parentheses, right? But there's no information about ion charges in the formula. But in the name, I have to tell you that it's cobalt 2. All right, remember, the Roman numeral tells you the charge of the cation. The cobalt ion had a charge of +2. I just highlighted it here in green. So I have a Roman numeral 2 after the cobalt in the name. So it's cobalt 2 acetate. Let's do some more formula writing. You can't be too good at this. You can practice and practice and practice it. Practice it until you're good at it. So if we have a compound forming between the tin 2 ion and sulfate, the tin cation has a charge of +2, and sulfate, the anion, has a charge of -2. Oh, well, if they react in a 1-to-1 ratio, the sum of the charges would be 0. So they are going to react in a 1-to-1 ratio, and the formula will be SnSO4. The name of the compound? Remember, tin is a metal that can form more than one cation. So we're told here it's got a 2+ charge, and so the name of the compound is tin 2 sulfate. The 2, the Roman numeral 2, is saying that the tin ion had a charge of +2, tin 2 sulfate. Let's do some more practice. The compound that forms between Al3+ and hydroxide, OH-. So right now they're side by side, and I'm looking at them in a 1-to-1 ratio. The sum of the charges would not be 0. I've got 3 pluses from the aluminum ion. I've only got 1 minus charge from the hydroxide. But if I had 3 copies of hydroxide, that would give me a neutral compound. So I need to write the formula as Al parentheses OH close parentheses 3. Notice I need 3 copies of hydroxide to make a neutral compound. +3 and then minus, minus, minus. The name of the compound, remember, it's the cation name and the anion name. So the name is aluminum hydroxide. Now aluminum is a type 1 metal. It only forms a +3 ion. It's the only thing it does. I don't need a Roman numeral for aluminum, so I'm not going to put it in. That's not the way the system works, all right? No Roman numeral for aluminum. So aluminum hydroxide, done. Figuring out names for ionic compounds with transition metals can be tricky because we have to sort of work backwards to figure out what the charge of the ion would be. So if the compound is Ca parentheses NO2 2, let's pull this apart. Cation is a group 2 metal. It's a calcium ion. Okay. And then the anion is the nitrate ion. I've got 2 copies of it, but it's the nitrate ion. So the name is calcium nitrate. Since calcium's a group 2 metal and it only ever forms a +2 charge, I don't need a Roman numeral, just calcium nitrate. Let's do another example. Mn parentheses ClO4 3. So cation is a manganese ion, but which one? Manganese can do lots of different things. We have to figure out what that is. But we also have that polyatomic ion, ClO4-, right? That's the perchlorate ion, which has a -1 charge. And I've got 3 copies of it. So I've got 3 negative charges total from those 3 perchlorate ions. And I've got 1 manganese ion, and I've got a neutral compound. So the logic here is that the manganese ion must have a charge of +3 in order for me to end up with a neutral compound. And therefore, the name of this compound is manganese 3 perchlorate. The manganese 3 is saying the manganese ion has a charge of +3, and then I've got the perchlorate ions. So the name doesn't tell me that I have 3 perchlorate ions, but I'm able to work that out. Let's do a little more practice with naming. CuSO3. All right, cation's always first. It's a copper ion. Copper can form a +1 ion or a +2 ion. Which is it? Well, let's look at the rest of the problem. SO3, that's a polyatomic ion. That's the sulfite ion. And the sulfite ion has a charge of -2. So I've got one copy of the sulfite ion, and I've got one copper ion. Therefore, the copper ion must have the opposite but equal magnitude in charge to the sulfite ion. So the copper has to have a charge of +2 in order for this to be a neutral compound. And therefore, the correct name of this compound is copper 2 sulfite. Cation name, anion name, right? The Roman numeral 2 is telling me that the copper ion has a charge of +2. Let's do another example. SN parentheses CrO4 2. Okay, so I've got a tin cation. Which one? I don't know. We'll have to figure that out. And then I've got CrO4, that's a polyatomic ion. That's the chromate ion. And it's got a charge of -2. I also noticed there's 2 copies of the chromate ion, right? Because it's in parentheses with that subscript 2. And I've got a neutral compound. So if I've got 2 copies of -2 and only one cation, the cation has to have a charge of +4. Right? The tin ion must have a charge of +4 in order for the overall compound to have a charge of 0. And therefore, since the tin must be a charge of +4, the tin ion is tin 4. And then we have the chromate ion. So it's tin 4 chromate. So you really have to be on your toes when you're working through this, and you have to know your polyatomic ions or keep that list handy as you're working. So let's summarize what we've talked about in this webcast. For metals that form more than one cation, you need a Roman numeral to indicate the cation charge. If you're supposed to have a Roman numeral in that name and it's not there, that's wrong. Most chemistry teachers, me particularly, were very, very particular about this. We're very, very picky. Formulas have to be neutral, so you're going to select your subscripts so that the sum of the charges will work out to be 0. If you need to show multiple copies of a polyatomic ion, you put that polyatomic ion in parentheses. You write the subscript outside the parentheses. And then we name ionic compounds by giving the cation name and then the anion name. And we have to remember to put that Roman numeral in, or we're going to not have the right name. And we don't want that. Of course, we don't want that. So if there's supposed to be a Roman numeral, make sure it's included. But if it's a group 1 metal or a group 2 metal or silver or zinc or aluminum, no Roman numeral. You have to remember that. So, do lots of practice problems. You're going to get this. If you found this webcast to be helpful, subscribe to my channel and leave a comment and keep learning chemistry. Do chemistry every day.